Hi, this video is about how fast reactions go, and it's called kinetics, or it's the rates of reactions. Well, first of all, you watched a short video about collision theory. Molecules have got to collide in order to react, and when they collide, they have to collide with enough energy to get over that energy barrier, that activation energy, and they have to collide in the right orientation in order for those reactants to form products. That's what we mean by a successful collision. It means that we formed products. So these rates of a reaction, or how fast a reaction goes, can be influenced by several factors, and we're going to talk about each one of these in the video. They are temperature and pressure, the surface area of the reactants, the bond strengths of the reactants, the concentration of the reactants, and the presence of a catalyst. All right, well, let's look at temperature and reaction rates. As you know from the last unit, temperature is a measure of the kinetic energy. And so if we increase the temperature, we're going to increase the kinetic energy of the molecules that are reacting. And so that is going to cause the molecules to collide more frequently because they're moving faster. So this is going to increase the reaction rate. So an increase in temperature will make the molecules move faster, collide more often, and will speed up the reaction. What about pressure? Well, when I think of pressure, the way I really like to think about it is with a piston. So like this would be like my reaction here. And then if I increased the pressure, it would push it down here. Okay, so this would be high pressure, and then compared to this, this would be the low pressure. So we're pushing down harder over here. All right, well, what's that going to do? Well, when you increase your pressure, you are going to be increasing the number of collisions. Also, the molecules are going to be closer to one another, so they're going to collide more frequently. So increasing the pressure will also increase the reaction rate. Surface area. All right, if you increase the surface area of the reactants, so, you know, if you had, let's say, a cube of sugar versus if you mashed it up and had all this fine powder of sugar, which would even dissolve faster? Now, dissolving isn't a chemical reaction, that's a physical change, but when you have a larger surface area, the reactions will happen faster because you have more area for the reaction to occur. So if you increase the surface area, the rate of your reaction is going to go up. And so whenever you see something like it was cut into smaller pieces, or it was powdered or whatever, increasing that surface area is going to make things happen faster. All right, now the bonds in our reactants have to be broken, and then the bonds in the products are formed. Well, if your reactants have really strong bonds, they're going to react a lot more slowly because it's going to take more energy to break those bonds. All right, concentration. Well, I like to think of concentration as how many molecules you have. And remember, they got to collide in order to react. So this guy over here, this would be a high concentration, and there are more molecules, so they're going to collide more frequently, and you would increase your rate of your reaction. Where over here, there's not as many molecules, and they're not going to collide as frequently. So the concentration of the reactants, if you increase it, the frequency of your collisions will increase, and so will the rate of your reaction. All right, now catalysts or enzymes are things that will speed up our reaction, and they're not used up in the reaction. You'll get them back at the end. And we learned this before. What a catalyst does is, this is an exothermic reaction here. What a catalyst does is it just lowers the hill. It's like just chopping off the hill. And so now this would be plus a catalyst. And biologists call a catalyst an enzyme, but they speed up the reaction by lowering that activation energy. All right, well, that's it. Have a good night.